In this video, we are going to look at an instrument that is used to analyze evidence, and it's one of my favorite. It is a scanning electron microscope, and a traditional microscope uses light and it bounces off the object to make that image. Now, a scanning electron microscope or an SEM or scanning electron microscope, it uses electrons and it shoots electrons down to the surface of an object, and then those electrons go back up to generate an image. So it looks more like a topographic map. And my first experience with an SEM microscope was when I had an instructor, and the instructor wanted to look at a piece of jewelry. And they wanted to look at the jewelry to see if it really was made of whatever type of jewelry you thought it was. So I had some silver earrings on, and I thought, hey, let's see if these are really silver. My boyfriend is about to get in a whole lot of trouble if they're not. Actually, I really didn't care. Now, a little cautionary tale for you. If your instructor ever wants you to give something to look at under a microscope, you need to be aware that there's going to be a whole lot of gross stuff on there as well, right? We just can't see all of the skin and gunk that is covered in our jewelry. Well, when you put it on a scanning electron microscope, you definitely can. So here is an example of an image from an SEM, and you can see all of these different types of substances, and you can actually identify what type of element is present. So in my case, my earring was silver. However, there was also a lot of gunk, and it was kind of an embarrassing moment for me as I had to stare at all of the Natalia schmag on my earring. It was gross. Here is where we can use an energy dispersive X-ray spectrometer. And we can combine that with the SEM to analyze all of this data that we get, all of this evidence that we get. So an electron is going to strike an atom with enough energy to force the inner core electron to leave the atom. And the electron from the outer shell drops down to fill the vacancy created. And in doing so, it releases a photon of light. So we can get these different signals based off of that, and it can help us identify what is present in our substances. So we have an unused firework and a burned firework, and we can identify all of the different substances that are present. What do you notice is missing? So this helps us identify different or analyze different evidence.